think this one's going to be a quick one. This is section 10.9. It's called linear programming, which is kind of a daunting name, but it's not too bad. If you understand how to graph inequalities, that graphing and shading that we did today and yesterday in class, this shouldn't be too bad. What a linear programming is going to look like is they'll give you a separate equation. I'll just call it z for simplicity, but z equals something. And then you'll be asked to maximize it with a given graph, or, and the problem we're going to do in a second, I don't give you the graph, but I give you the inequalities, and you'll have to graph those to generate the shaded region. So this one, the region is given to you, and the way we do this, if this is the function I want to maximize, you first have to find the corners of the region. And corners are exactly what you would expect them to be. They are the corners. Yes. So my corners are 0, 6, 5, 6, 0, 3, 4, 0, and 5, 2. And what we'll do is we'll simply plug in each one of those ordered pairs for z. So we'll have a different xy ordered pair. And I'm going to make a little table. And then we have z, which is 10x plus y. And in this table, one at a time, I'm going to plug in each of those ordered pairs. So we have 0, 6. And that if x is 0, so that'd be 10 times 0 plus 6, you get z to be 6. And I'll plug in the next corner. So I've already plugged in 0, 6, and I'm going to plug in 5, 6. And so z is going to be 10 times 5, which is 50, plus y, which is 6, and 50 plus 6, 56. Plug in the next one. Let's see, so I've done 0, 6, I've done 5, 6, let's do 0, 3. So z is going to be 10 times 0 plus 3, which is 3. My next corner is 4, 0. So z is going to be 10 times 4 plus y is 0 is equal to 40. And then my last point, which is the corner 5, 2, which I got right here. 5, 2 gives me z to be 10 times 5, which is 50, plus y is 2, gives me 52. And then we have to go back and see what we're looking for. In this case, we're looking for the maximum. We're wanting to maximize it, and the maximum occurs at the point 5, 6. So the way we would word this answer is we have a max value. My max is, I actually got 56, so that was my max, and it was at the ordered pair 5, 6. And so that'll be your answer. And that's all there is to it. You graph and shade just like we did yesterday, but then once you're through shading, you plug the corners into the equation. So here's another one. We want to maximize that given these constraints. I'm looking and I immediately see x and y are both greater than 0. And I'm seeing that right here, x is greater than 0, y is greater than 0. That automatically limits me to the first quadrant. So I'm only going to draw the first quadrant. If x is greater than 0, that's the y-axis. So this is line x equals 0. If I want x to be greater than 0, we'll shade to the right. If y is greater than 0, that's your x-axis. So that's line y equals 0. And if y is greater than 0, we're going to shade up. So I'm in the first quadrant. Okay, then let's see. This one I'm going to have to do a little bit of work. Not too bad. I'm going to move that x over. Y is greater than equal to negative x plus 3. That's going to give me a y-intercept of 3. And I'm actually going to, let's see, 1, 2, 3, 4, 5, 6. Yeah, I'm going to go up by 2s, where this is. I'm going to let that be 1. I'm going to let that be 2. There's 3. Here's 4. Here's 5. I probably should have done this at a time. 6, 7. And then same thing down here. 1, 2, 3, 4, 5, 6. And then we'll start graphing. So negative x plus 3, a y-intercept of 3, and a slope of negative 1. So I'm going to go down 1 over 1, down 1 over 1, down 1 over 1. And graph a whole bunch of points because these really need to be accurate. You can't just kind of halfway graph these. They have to be real accurate. And so this graph looks like this. It is a solid line because it's also equal to and greater than. If you plug in the origin, this one's going to end up shading up. So we're going to shade this way. And then my last two are kind of simple. x is less than equal to 5. If I were to graph x equals 5, that is a vertical line at x is equal to 5. So here's 5, so I'll graph a vertical line. And I want x to be smaller than 5. So numbers that are smaller than 5 are going to be on the left. So now I'm shading this way. I'm shading this way. Shading this way. Y is less than equal to 7. That's a horizontal line. Y equals 7 is a horizontal line at 7. So I'm going to graph y is less than equal to 7. So the blue line, y less than equal to 7. The red line was x less than equal to 5. The green line was the x plus y is greater than equal to 3. And let's see, back to this one. Y is less than 7. We're going to shade down. And the region they all have in common is this region in the middle. So there's my shaded region. And now the easy part, I'm going to make my little table. I'm going to find my corners. There we go. Find my corners, which, let's see, now my corners, I see one at the ordered pair 0, 3. I see another one at the ordered pair 0, 7. I see another one over here at the ordered pair 5, 7. And this is why it's important for you to graph accurately, because you need the specific points. You can't be just kind of right. There's another corner at 5, 0, and another corner at 3, 0. And we'll plug them in one at a time. My equation that I want to maximize is x plus 3y. And then one at a time, we're going to plug this in. So 0 for x plus 3 times 3 for y is 9. That gives me 9. And then we'll keep going down for the sake of time. 0 plus 3 times 7 is 21. And for the sake of time, I'm not going to plug all of these in. I'm going to pause it, and I'll be right back. All right, I just finished plugging in all those other ones. When I plugged in 5, if you look at 5, and this is just simple arithmetic, you're just plugging in for x and y up here. And 5, I was asked to maximize it. When I plugged in 5, 7, there is my maximum. I got 26. My other ones were 9, 21, 5, and 3, so that's my largest. So my answer, we have a maximum of, my max value is 26, and it occurs at the point 5, 7. So that's how you do this. And we'll just do one more. I think one more. What's that? Oh, yeah, I don't need that stuff before. All right, so one last problem. One last problem. We have a few more equations this time. I'm going to have to be a little bit careful here. But again, the first thing I notice is I have x and y are both greater than 0, so I'm automatically limiting myself to the first quadrant. I'll limit myself to the first quadrant. And so yeah, as soon as I see these two, I really don't think too much about it. That just tells me that I'm confined to the first quadrant. So I know I'm going to be shading to the right of the y-axis. I know I'm going to be shading above the x-axis, because x and y are both positive. This one, if y is greater than equal to, if I move that x over, negative x plus 2, that gives me a y-intercept of 2 and a slope of negative 1. And so that line's going to come down like this. And y is greater than, that's going to shade up. So I'm going to go this way. Okay, next one. This one's going to be a little bit cumbersome to solve. 3y is less than equal to, move the 2x over, negative 2x plus 12. Divide everything by 3. And you get y is less than equal to negative 2/3 x plus 4. So now I'm going to go up to 4. And this one, I'm going to go down 2 over 3. Slope is down 2 over 3. Down 2 over 3. Graph that one. And let's see, y is less than. That's going to shade down. And if you plug in the origin, if I plugged in 0, 0, you get 0 is less than equal to 4. That is true. So we will shade towards the origin. And right now I'm kind of keeping an eye on where I'm supposed to be shading. My common area so far is that region right here. So I'm kind of keeping an eye on that little bitty yellow region. So I've got a whole bunch of wasted space up there. Didn't see that coming. I do have one more line to graph. This one's not going to be as bad. This one, all I need to do is move that 3x over, so negative 3x plus 12. So we're going to start up at 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And my slope is negative 3, so down 2, 3 over 1. 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 Oh, geez. This one's going to be painful. Down 2, 3 over 1. And then graph that line. And let's see, y is less than. That's going to be shading down. I'm going to be shading towards the origin, shading down because it's y is less than. And now I finally can see my overall region, and this one introduces a funny problem. I'm kind of glad I did this one. This is the overall region that they had in common. All of this stuff right around in there. Finding the corners is going to be a little bit of a pain. There are 4 sexy corners. I have 1 corner. So let's see if I list my corners. My corners are, I have a sexy one at 0, 2. I have a sexy one at 0, 4. I have a sexy corner at 2, 0 right here. Sexy corner at 4, 0. Now the problem here is we have an intersection right there that is not a sexy point. So we have to find the intersection of those 2 lines. And it's a good idea to keep in mind where your lines are. And I can have mine color-coded. If you want to use colored pencils, I'm fine with that. But this is the green line and the blue line. And I have to find the intersection of those. So that's this line. There's the green one. And this one is the blue one. And the way we find where those intersect is we have to solve a system of equations. So I'm going to come over here, and I have the equation 2x plus 3y. This is my green one. And I'm just going to treat it like equals 12, which is fine for this purpose. 3x plus y is equal to 12 also. And we're going to solve this with elimination. And the way I'm going to do this is if I multiply the bottom equation by negative 3, that gives me negative 9x minus 3y equals negative 36. This top one up here, don't need to change. Then we solve this. Oh my gosh, this is going to be bad. 2 minus 9 is negative 7x. The y's cancel. 12 minus 36 is negative 24. So my x coordinate is 24 divided by 7, which is painful because that's one of my... Did I do that right? Hang on, I'm going to pause this and double check my work. Yeah, unfortunately, I think I'm right. This is painful. Now that I know what x is, I'm going to have to plug it in to solve for y, and I'll plug it into that top equation right here. And so that would be 2 times 24 over 7 plus 3y is equal to 12. And I'm going to pause it and solve this for the sake of saving time. I solved it, and I got y equals 12 sevenths, which I've already plugged in down here, and I've started my table. And I'm maximizing my equation as 5x plus 4y. 5x plus 4y. And then one at a time, we're going to plug all 5 of these points in. All right, so I just plugged them all in. And this one was ugly for a little bit because you had to plug in 24 sevenths and 12 sevenths and multiply them by 5 and 4. But when you added them, you did get a kind of a nice answer in the end. And notice this time I'm looking for the minimum. You have to pay attention. I want to minimize this. So now I'm looking for the smallest answer, which is actually at the point 0, 2. Because I got an 8 there, and all my other numbers were higher. So I would say I have a minimum of 8, and it occurs at the ordered pair 0, 2. And that's it.